Okay, start our 10-minute timer. All right, here we go. Will, you have a question or are you stretching? Okay. All right, so today we're talking about scientific notation. Scientific notation is any number written in the form a times 10 to the n power. That is scientific notation. A times 10 to the n power. Okay? Oh, whoa, sorry. Oh my gosh. Any number written in, this should be scientific notation. I'm getting ahead of myself. Scientific notation. And it's in this form, A times 10 to the n power. I'm sorry. So scientific notation is written in the form A times 10 to the n, where A has to be bigger than 1, but less than 10. A can equal 1, but it can't equal 10, meaning that you can only have one decimal. A decimal in the ones place, you have something in the ones, and then a decimal, and then you can have tens, hundreds, thousands, but you only have a ones place value. And the n has to be an integer. So no fraction, no rational exponents, it has to be an integer. It can be positive or negative, but it has to be an integer, okay? So, the first thing that we're going to do is just write some numbers from standard form into scientific notation. So, thinking about what we know, we have to have this number. How many decimal places can we have to the left of the decimal? That's to the right of the decimal. To the left of the decimal. So the decimal is right here. Do you guys see that?
Yeah.
To be in scientific notation, this value right here, that first number, cannot be, it has to be in between 1 and 10. So 4.5. So let's see what I actually am doing. I'm moving the decimal 1, 2, 3, 4, 5, 6, 7, 8 times. So times 10 to the 8th power. So 4.5 times 10 to the 8th means that this number is going to be 8 times 10 larger, right? 10 to the 8th power larger. So I'm going to make this number larger. So what do you think is going to happen when I look at something like this that's already very small? Kaden?
It's going to have a negative exponent.
It's going to have a negative exponent. So let's write this in scientific notation. So let's look how many times I have to move the decimal. 1, 2, 3, 4, 5, 6, 7, 8 times. So I end up with the number 8.2 times 10 to the, Kaden said, negative exponent. Okay? So looking at a number, because this is a positive exponent, I know that in standard form this is going to be bigger. Because this is a negative exponent, when I write this in standard form, it's going to be smaller. Does that make sense? How that works? Questions about that? Okay. Have you guys done scientific notation before?
Yeah.
A long time
Okay.
ago.
Probably 5th or 6th grade, right?
Yeah.
I remember we did a little bit last year.
Did you do some last year? Okay. All right, scientific notation to standard form. So now we're going to go from scientific notation to standard form. So what did we say about a negative exponent? When I have a negative exponent, I know that my number is going to be
Like way less than 1.
yeah, much smaller than the one I started with. So a negative exponent means that I move to the negative exponent means that I move to the left. So I'm going to take my 5.8 and I'm going to put it right here. I have to move my decimal to the decimal place to the left how many times?
4.
4 times. 1, 2, 3, 4. So my decimal is actually going to end up right here. I'm just going to put zeros in there as placeholders. So my new number is actually 0.00058. And if I say it as a decimal, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, 5,800 thousandths. It's just easier to say 0.00058, but anyway, just wanted to show. Okay? What about the next one? 4.051. How are we going to do that one? Cameron?
Move the decimal over to the right 6 times.
Yeah, we're going to move this decimal to the right 6 times. So I'm going to rewrite it, 4.051, and and I have to move the decimal 6 times. 1, 2, 3, 4, 5, 6. Fill in some zeros there. So I really have 4,051,000. Okay? We use scientific notation to write really big numbers, more compact, or really small numbers. So if you think about a giga or a pica, if you guys are going to be chemists, how many of you guys like chemistry? I mean, you're going to use scientific notation a ton in chemistry, okay? Good there?
Yeah.
So in your homework, you're going to have to write a number that's in standard form, this is called standard form, to scientific notation or vice versa. Take a number in scientific notation and write it in standard form. Good? Okay. Sometimes you're going to have to evaluate, meaning do some kind of mathematical operation. I have 2 examples where we're multiplying, then I have 2 examples where we're dividing. This was just like number 15 and 16 in your homework yesterday. Remember I said we have a whole lesson dedicated to that? Here it is. So, tell me what you know about exponents.
I was gonna ask a question, but if you plug that equation into your calculator, can you do it without having to like do it like manually?
Well, this isn't an equation. This is not a variable. This
Yeah.
is actually an x. So, but you can plug this into your calculator. 5.4 times 10 to the negative 4 power times 6 times 10 squared. Absolutely. The answer that it's going to give you is probably going to be in standard form. Okay? Because you have to write your answer both ways, in standard form and in scientific notation. So yes, you could plug that into your calculator. But let's pretend that we are roaming with the dinosaurs and we don't have a calculator. All I have is my brain. How could I do this with just my brain, not a calculator? Oh, sorry, Levi.
Well, you multiply 6 times 5 to get 30,
6 times, let's just do 6 times 5.4.
and that'd be 32.4.
32.4, I think.
Yeah.
Okay.
But you know that, well, and then we're gonna add those together because it's multiplying, and that'd be 10 to the negative 2nd power. But we know that since 32.4 is greater than 10, we have to reduce
Well,
it.
hang on a second. You're getting ahead of yourself. So say what you said again. Because the base is the same, I add the exponent, so I get what?
10 to the negative 2nd power.
Okay, so hang on one second. If I wanted to write this in scientific notation, have I done that?
No.
No. What do I need to do? Yep.
You need to add an exponent to it, and then move the decimal one to the left.
Yeah, I have to move the decimal one more place to the left. I need to make it look like this. 3.24. Right?
Yeah.
So because I added a space, this is going to become 10 to the negative 1. Okay, so this is in scientific notation. What if I have to write it in standard form? Did any of you guys try this green method in your calculator? If I wanted to put this in standard form, what's that going to look like?
0.324.
Yeah, 0.324. I can go to the original and just take the decimal, move it 2 places to the left, or I can look at my next one and move it 1 place to the left. 0.324. Okay? What do you think about that?
Good.
Okay. What about example number 6? I'm taking a product and raising it to a power. What do I do with that? Think about your exponent rules.
Multiply the exponent.
Yeah, I have to distribute the exponent, right? So this is really going to become 2.4 to the 3rd power times what?
The negative 12.
10 to the negative 12 power. Okay? So what is 2.4 to the 3rd power?
13.824.
So 13.824 times 10 to the negative 12. Now what?
Move the decimal place 1 spot over.
So I'm adding a place value here, which means I have to add a positive there. So what's my new exponent going to be?
Times 10 to the negative 11.
Awesome. Times 10 to the negative 11. So this is my scientific notation. Go ahead and stop it, and I'll stop that video in a second. This is my scientific notation. What is my standard form gonna look like? What do you think, Mr. Johnson? Yeah?
Okay. So you would go. Wait, in standard form?
Mm-hmm. What do I have to do with that decimal?
You have to. Don't you have to do the 10 times to the power?
Yeah, what's 10 to the negative 11 tell me to do, Colton? Yeah, I have to move that decimal to the left 11 times. So this is what I'm going to do. I'm going to start with a 0 and then a decimal place. If I move this to the left 11 times, 11, 10, I'm going to have 9 zeros. 1, 2, 3, 4, 5, 6, 7,
You would have
8,
10
9.
because of the bottom one.
Oh, got it. 10. Sorry, thank you. And then 1, 3, 8, 2, 4. Would you like to have to try to write a number like that on a regular basis?
No.
That'd be awful, especially if you were typing it into a little cell, right? Think about the space that you have to type stuff. So that's horrible. That's why we use scientific notation. Okay, I'm going to stop our video and start it again for the last 2 examples.